When we take a toke of cannabis smoke or vapor, we can feel it in our lungs. Our lungs are very efficient in swooping up cannabinoids and plugging them into our bloodstream to be distributed around the body. This inhalation begins a cascade of bodily reactions throughout us. Most of us take them for granted nowadays. These reactions happen all over our body in subtle ways and significant ways. Some are medical, some are funny. In all our ways, our body is rebalancing itself in the presence of phytocannabinoids. Today, we're going to take a look at the human systems that fire up in the first few minutes of using cannabis. If you want to learn about cannabis health, cultivation, and technique efficiently and with good cheer, I encourage you to subscribe to our newsletter. We'll send you new podcast episodes as they come out, delivered right to your inbox, along with commentary on a couple of the most important news items from the week and videos too. Don't rely on social media to let you know when a new episode is published. Sign up for the updates to make sure you don't miss an episode. Also, we're giving away very cool prizes to folks who are signed up to receive the newsletter. This month's giveaway sponsor is Fish Poop brand Fish Poop. Fish Poop fertilizer feeds plants and microbes and improves soil structure with rich organic matter. It contains available nutrients for quick feed and undigested organic material for slow release with a wealth of beneficial organisms. 5 lucky winners will receive a whole gallon of fish poop along with some fish poop swag. So go to shapingfire.com to sign up for the newsletter and be entered into this month's and all future newsletter prize drawings. If you like what we do and want to put something in the tip jar, you can Venmo at Shango Los. You are listening to Shaping Fire, and I am your host, Shango Los. Welcome to episode 123. My guest today is Dr. Elizabeth Thompson. Dr. Thompson holds a PhD in pharmacy emphasizing cannabinoid pharmacology, a master's in clinical physiology, and a BS with honors in microbiology and genetics. Her current research focus investigates the various roles of cannabinoid molecules in elite contact sport athlete populations. Currently, Dr. Thompson is a member of the groundbreaking research team partially funded by the NFL to investigate the use of cannabinoids to reduce brain and neuroinflammation caused by concussions. Today's episode is about the first 5 minutes after smoking cannabis. During the first set, we will talk about inhalation, the respiratory system, taking and holding big hits, bronchodilation, and asthma, and the changes to your cardiovascular system, vestibular dysfunction, bloodshot eyes, and blood pressure changes. During the second set, we focus on the endocannabinoid system and nervous systems, binding to CB1 receptors, the biphasic nature of cannabinoids in the body, and how to use CBD more realistically and effectively. We also look at psychological states and mood generally right after you toke. And we will look at changes in your coordination too, and look at why sometimes cannabis makes us perform better, and sometimes it makes us perform worse. And we wrap up the third set talking about edibles and how our body changes delta-9 THC into 11-hydroxy-THC and why that makes edibles truly a different drug than inhalation. We will also talk the importance of rectal and vaginal suppositories and the process they go through when inserted into your human. All today on Shaping Fire 123. Welcome to Shaping Fire, Dr. Thompson.
Hey, Shango. How are you today?
So great, so good, and really glad that you're able to join us. Congratulations on your recent successful PhD. We're all proud of you and happy to have another strong cannabinoid researcher in the mix as you.
Thank you so much. And I will tell you a really quick story, but the very first person that I ever heard that piqued my interest in cannabinoid pharmacology was actually on your show. And it was Dr. Metabolic Shields, who is one of my favorite humans ever, but it was actually on your show, I think maybe six or 7 years ago.
Fantastic. Oh, I love those episodes with Miyabi Shields as well, especially all the biomechanics, which makes sense since that's the same reason you're here today as well. So, yeah. Shout out to Dr. Miyabi Shields. So thank you for that.
Yep.
So let's see. So first of all, let's remind folks from the intro that the episode today is about the physiological reactions that the body makes when consuming cannabis in the first 5 or 10 minutes after toking. And we'll talk about edibles and suppositories in the third set. So we're mostly assuming that we're talking about inhalation, since that's what most folks, how most folks use cannabis. And I think this is a good point that we talk about individualized medicine. And I'm sure you run into this all all the time, Liz, that just because we're talking about bodies generally does not describe anybody's body in specific. And so even though we're talking about these ways that the bodies can act or generally act, that people's bodies are unique, and for us not to assume that it's the same answer for everybody, right?
Yeah, absolutely. And actually, I cannot think of a space that applies to stronger than cannabinoids and cannabinoid pharmacology, because when we're looking at, and this is why I really love this, my master's degree was in physiology. And so I'm a really big nerd on molecular mechanisms and systems and stuff. And, when you're looking at humans and you're looking at invoking any kind of change, I always compare it to the seed in the soil, right? You can have a plant seed, and depending on what kind of soil you're plopping it into, that seed's either going to grow or it's going to grow funny or it's going to die, depending. And so for me, I look at a human body as like the soil, right? All these soils are different, and how things play in that soil is super individualized. And the endocannabinoid system is an incredible neurophysiological system that I love so much. And, pharmacologically, when we are looking at how these molecules work, there are definitely some generalizations, but really the biggest generalization is that everybody is unique for sure.
Good. So I will be asking you some questions today that may seem unfair, like some why questions, right? And why is always really hard in science. I know. But since you have got this, you've got a real gift for translating some of this hard science into, usable stuff for laymen, which is one of the reasons why I invited you on the show. So when I ask you some of these why questions, first of all, I encourage you to indulge me, but then also, feel free to put the science together into, some storytelling that you think makes sense. I just want to call that out in advance, because I know that the why questions are kind of unfair to ask a scientist, but in this realm, I hope you just roll with me.
Okay, for sure, I will. And actually, as a physiologist, I love the why questions, because it kind of, especially again in pharmacology, a lot of medicines, we don't look at the why. We're just trying to we're covering a symptom with a medicine, and we're not asking the right question. And the question is, why is that symptom happening? The symptom isn't the problem. The symptom is the result of a problem. So why is that symptom happening? And that is true physiology, is you're going upstream to find why is there a problem? And so, yeah, I might not be able to answer all of your whys, but I will try my best.
Excellent. All right. Well, then I guess let's start going downstream from the moment that that the cannabis enthusiast takes a hit from their pipe or bong or whatever. The first thing that happens is that they are inhaling into their lungs. Now, I've got a handful of specific questions, but would you just give us a brief explanation of the next couple steps? They inhale. And what happens physiologically?
Yeah, for sure. So when you inhale, you're inhaling just the exact same thing happens as if you were just inhaling normal air, but now you're inhaling air that contains cannabinoid molecules. And so when you inhale air, you have to think of your lungs kind of like a tree. It's an upside down tree. So you have your oxygen intake is coming in and it's traveling through your nose and your mouth. And then it's going through the big thing that looks like a trunk, your bronchi, and then it's going down into smaller branches. And at the very end of those branches are alveoli, which are essentially the leaves. And in those little things, the little alveoli kind of look like balloons. That's where your oxygen is going to exchange with carbon dioxide. So in a normal breath without cannabinoids, you're bringing in oxygen. So when you inhale and then when you exhale, you're breathing out carbon dioxide. Now, when you're inhaling, you're taking a toke, with your air is coming in the cannabinoids. And so that same exchange is happening, but with the oxygen is going in the cannabinoids, and it's going to go to the same place. It's going to cross your lung barrier right into your circulation system, and it's going to start circulating just the same way oxygen would. It's going to roll through your circulatory system, and it's going to go right up into your brain, and it's going to go into all the tissues and all the other places in your peripheral circulation as well. So it's kind of like a ride. That's the best explanation I've ever heard. Thank you for that. One of the things that always is remarkable to me is how fast it happens. In medical cannabis, we talk a lot about, the various ways to use cannabis for different types of
ailments. And we always talk about, well, inhalation is the fastest onset because the time from inhalation hitting the lungs, into the bloodstream, into the brain, taking action is so short. Like literally, can be as little as 10 seconds in some cases, so fast. And the lungs must just be so efficient to be able to take in cannabinoids at the same rate that we take in oxygen.
Yeah. Yeah. I mean, and also it depends on your blood volume or on your lung volume, right? So how big your lungs are. So I specifically work with athletes and some of them have incredible lung volumes. And so those are the things that even, the generalizations of inhalation are one thing, but when you start getting into the specifics of each individual human, some of these guys that are trained, their lung capacities are amazing. And so the amount of air that they can potentially take in, expanding the lungs, and then you have sensors when your lungs expand that do all kinds of things. And so, yeah, it is incredible, actually. But you would think of it the same way that you think of oxygen, right? We need oxygen immediately and to be sustained also in order to live. And so it's really riding the same wave as normal oxygen would be. So anywhere oxygen's going, that's essentially where your cannabinoid molecules are going to roll into as well. Cannabinoid molecules are lipid-based molecules, so they are going to get into the fatty tissue. But that's one of the advantages of it as far as when, again, one of my main focuses is on concussion. And so because cannabinoids are lipid-based molecules and your brain is made of fat, that's actually an advantage to us to be able to get that up into the brain and where we need it to function. And so when we're looking at head trauma, you would think, okay, if somebody got smashed in the head, and there are different applications, different administration routes for cannabinoids have different advantages, and the advantage or the disadvantage, depending on the context of inhalation, is that it's fast. And so if you have a potential concussion and you have massive neuroinflammation happening in your brain and you inhale, you can immediately get those cannabinoid molecules right up into your brain. And that's what you want to do. You want it to be fast. Now, if you were somebody that had something like, say, arthritis that is more of a slow burning pain, well, because inhaling is fast on, fast off, right? So that might not be the best administration route for something like arthritis, because you want to be able to have a sustained pain reduction, say overnight. Well, that would be someplace where maybe an oral tincture or potentially an edible that has a slower onset, but it also has a slower offset. And so, in pharmacology, we can look at what are we after? What are we trying to do? And then look at the different administration routes to see if that's going to be an advantage for us. And inhalation is definitely an advantage potentially for concussion. And also, migraine, headache, acute pain, things that need to be immediately addressed. So I think the biggest thing in cannabinoid pharmacology or anything to do with cannabinoids, and my own kids want to slap me when I say this because they ask a question and I always say context matters. Like, you cannot paint this with a broad brush stroke because the context of what you're asking matters. So, what cannabinoid are you using? What is the human you're looking at? And so I think that's one thing, and this is completely off topic, but I'm going to say it because I don't feel like I'd be a responsible scientist if I didn't, that I think right now in the space of cannabinoid science, as scientists and researchers and people that are speaking about the benefits of these molecules, I think we need to be really careful about how we speak about them when we are speaking about cannabis, quote unquote. Cannabis is 500 different bioactive molecules, and they're all different, right? So when somebody says, well, what does cannabis do? Okay, well, are you talking about THC, or are you talking about CBD, or are you talking about CBG? What are you talking about? Because they all do different things, right? So I think we really need to focus on the context of what we're saying. And then the flip side, you have media that are sensationalizing headlines, and they're saying, cannabis causes heart attacks. Okay, well, that's not necessarily true. What in cannabis are you talking about? Are you talking about a synthetic cannabinoid? Are you talking about THC? CBD doesn't cause heart problems. I think we have to be really careful and be more specific, and also with the patient population or even the data sample that we're working on. When we come up with data, I'm focusing on athletes. My data pertains to athletes. They are high performers. They are not sick. They are people that have a different body mass. They have their body mass index as high muscle, low fat, lots of circulatory benefits. That is not the same as somebody who is extremely overweight, who is injured, who has other pathological problems. And so I think we have to be really careful when we're talking about what data is out there to be sure about what we're looking at and how we're interpreting it. And same thing, you know, when it goes for the brain, an example I'll often use, you know, when people can't really differentiate between, they have a hard time, I think, publicly wrapping their head around how even an inhaled product. So we're talking about inhalation. I did get off path here, but what are we talking about? You know, if you have somebody that's had a concussion, right? This brain is massively inflamed. So inhaling, good idea, versus an adolescent child that has their brain is developing. They don't have any inflammation. They don't have any reason to be looking to change and alter their endocannabinoid system. Those two brains are not the same. You know, those are two very different contexts that we're looking at. How are we going to use these cannabinoids and why? And I just feel like we need to now, because we are putting out more data and the media is starting to hop on all these, you know, sensationalized titles, you know, for clickbait or whatever. And they're confusing people, I think. So that was my tangent.
Right on. Well, you're definitely accurate about all of that. And I like your idea that, you know, one size does not fit all, which was the point we were trying to make. And I really like your phrase that inhalation is fast in, fast out. I think that those of us, you know, this audience is pretty sophisticated when it comes to cannabis. And we're all familiar with that, but that phrase really brings it down in a way that makes it really easy to communicate with people. While we're talking about the lungs, I want to talk about the myth of holding hits, because I can't bring this up enough. We have had other cardiovascular and respiratory scientists on the show, and it's always important to bring up that we've been taught to hold our hits so that we can get as much THC and other cannabinoids out of it. But that's not really how the lungs work, and it's really better if you just inhale and exhale naturally. Would you just hit on this briefly and kind of explain the science behind that? I just want everybody's lungs to be healthier.
Yeah, for sure. I can do the best, the best that I can. Again, we don't look so much at the details of, inhalation and trying to get as much cannabinoid concentration as possible. But when you look at how your lungs function, there's a few things that you mentioned. There is, when you breathe it in and you just hold it, your lungs are just staying still, right? Your lungs have sensors on them that when they expand, that's giving information to your body about what it needs to do. And so when you're just holding it, you're not sending any messages for your lungs to diffuse it faster or more. It's just, and what you're doing, you're essentially holding your breath, which, I mean, we've all done it when we were 8 years old to see how long we could hold our breath, and we all fall over and whatever, but all you're doing there really is holding your breath. And that's really, you want to be as safe and as natural as possible with your body and the way that it's supposed to be functioning. So a nice breath in and a nice breath out, you're going to be exchanging the oxygen and the carbon dioxide that is supposed to be getting exchanged in that, but you're just including the cannabinoids in with the oxygen as well. So there's no advantage to sitting and holding it. In fact, you're just going to get lightheaded because you're essentially just holding your breath.
Beautiful. Beautiful. Thank you. So, anybody who listens to the show regularly knows I've got asthma. I tend to talk about my asthma a lot. And one of the things that I can't say that it attracted me to cannabis, because I found out it was a bronchodilator after I was already using cannabis. But, people said, oh, it's, the cannabis that you use must be helping your lungs. But for me, my experience with cannabis was smoking it until I coughed. And then it would, this seizing feeling in my lungs. And then that would eventually pass, and then I would take another hit, right? And so I've never really quite understood this, what seems like a contrast to me, that cannabis is a bronchodilator, while also I experience as bronchial constriction. And my only guess is that you're going to tell us it's from particulate, but how can both of these be true?
So it could be from particulate, but that's a different mechanism altogether. So what I would say and what you described there is that isn't necessarily, when you're coughing, that isn't necessarily bronchial constriction, that's bronchial aggravation. And so when you start coughing, it's because something has been triggered that's aggravating either your breathing way or your lungs, and you're starting to do, it's a muscle spasm essentially to try to bring up whatever is aggravating that air passageway. So there are things that do bronchial constrict. For example, and one example that we see a lot actually, and is when people mix their cannabinoids or their cannabis flower with cigarettes, because cigarettes are actually constricting, but cannabis is actually dilating. And so people think, okay, well, if I mix them together in a spliff, then they're going to, wipe each other out or neutralize each other. And that doesn't actually happen either, because again, when you think about your lungs being like a tree, all those branches, okay, so now pretend it's a water tree and there's water flowing through the trunk, and the water is flowing through all of those different branches like hoses, right? And if you grabbed a branch and you folded that hose in half, now you constricted that branch. But what it did was it forced the water to go to a different branch, right? So you're playing with the levels of the pressure. And so in your lungs, when you roll your cannabis with tobacco as well, in a cigarette, or you put it together, you can actually have constriction and dilation at the same time, but not in the same place. So different branches would have different, you inhale these molecules and different branches are getting different signals. Our body is one humongous signaling machine, and there's signals being sent all the time. So, for asthma, it is true. Actually, it's kind of cool. But back in, ancient times, they used to use cannabis as a treatment for asthma. That was what they used it for. And because it is a bronchodilator, and so it can open up the air passageway so you can get more oxygen into your lungs, which then goes into your body to feed all of the tissue and the muscle and stuff. So, but I would say that if you start coughing, for sure, it could be particulate. And we know, there is also, some byproducts and stuff that could potentially be irritating to the actual tissue of your lungs.
Sure.
And that's going to start sort of kicking. Those branches are going to start tweaking sort of, and that's going to cause you to cough. Right. And so some kids actually have, asthma in general, not even with cannabinoids, it can start triggering their lungs to kind of freak out, and they just start coughing, even without cannabis. But it's actually asthma-induced, coughing. So it's a trigger. It's, again, nerves, right? Nerve signals, and then it's muscle spasms. And so THC is also kind of a muscle relaxant as well. And so it bronchodilates, but it also does relax those muscles that are sort of triggered and coughing. And so, yeah.
Great. Excellent. All right. So as far as we're moving downstream from the toking moment, so we've inhaled it. We know we don't want to hold our hit in. Hopefully we don't get any bronchial response and coughing. And so we've got a little bronchial dilation, which is making us feel smooth and easy. And so now the cannabinoids are into our blood system, and now we've hit the cardiovascular system, our heart and blood flow, and we're to this point sometimes like within a minute, and so let's talk about that. So what's the better way to discuss this, Liz? Is it better to have you explain these next parts, or should I start asking you questions about it because the reactions in the body are so spread out?
They are definitely spread out, because we have to remember that the endocannabinoid system and these receptors that these molecules are interacting with are everywhere. And I'm sure that, your audience probably has a baseline understanding of how cannabis is even working in general, but it has everything to do with your endocannabinoid system. And we have to remember that these receptors are there everywhere in our body to naturally accept molecules that are stereochemically almost identical to things that we secrete ourselves. So I think sometimes it's hard for people to sort of think, well, like, why are these cannabis molecules rolling around and doing all of these things to me? And actually science didn't even know why until we isolated. I think Howlett isolated the first receptor in 1988. So this is a baby science. Like, understanding our endocannabinoid system is a baby in science years. But to really recognize what we're doing, we have to give, again, shout out to the endocannabinoid system, because it is everywhere, and it is normally receiving molecules that you secrete yourself. So really, there is no place in your body that these molecules are not going to affect, right? They can affect so many different things.
So chemically, mechanically, what will happen once it hits the cardiovascular system is our blood vessels will dilate, which will decrease our blood pressure, which increases our heart rate, right? So to us as a consumer, we feel suddenly sped up, and it's at the core of it, it's because the blood vessels have gotten a little flimsy, and so it kind of softens our blood pressure, right?
Yes, exactly. And so a good way to think about that, and that was a really good explanation, is your body is very, there's a lot of sensors. Like I said, like everything is a sensor in one way or another, and it's telling another part of your body what's going on in its neighborhood, you know? And so a reductionistic view of the body, which again, sometimes in pharmacy, things are very reduced. They're monomolecular targets that these drugs are trying to hit, and they work for certain things, but they're ignoring all the other neighborhoods around that one, town that the molecule is trying to affect. And so when you're thinking about how those things work in your body, as far as like your blood vessels dilating, so you inhale it, your blood vessels dilate, but there's triggers. So that's a sensor, and your body picks up on that, and your heart's like, holy crap, there's no blood pressure down there. Unless she wants to faint, I got to speed up because we need to pick up the pressure. So they get the blood starts moving faster to increase the pressure so that there's some tension against the walls of your arteries, so that it doesn't feel so flaccid. And so anybody that has POTS or, any kind of low blood pressure regularly, just by nature, a baseline low blood pressure will know, when they stand up too fast or when they make sudden movements, if they don't have their sensors, their sensors aren't able to adjust as quickly as somebody that doesn't have POTS or, orthostatic tachycardia. So it's the sensors. And so your body's doing what it's supposed to be doing. When THC dilates, your body does exactly what it should be doing. It recognizes, holy crap, the blood pressure just dropped, speed the heart up, and it's working. Your body's amazing. It's doing exactly what it should be doing. Now, it freaks people out sometimes because they're like, oh my God, my heart's like mega racing. And, then depending on how much THC they use, they might completely freak out, but...
Well, for freaking out can sometimes be part of the rite of passage. Unfortunately, we'll talk about the biphasic nature of THC here in a little bit. I do want to flag what you said about POTS. I do have POTS, and for anybody who is listening, who when you have a toke and then you go to stand up, if you tend to get more dizzy, if your vestibular system tends to be more off than other of your friends, give a little search on Google or similar for POTS. That's postural orthostatic tachycardia syndrome. And this isn't an episode about POTS, so we're not really going to go into it. But suffice to say that cannabis makes it a lot worse. And I found out about POTS on a podcast and looked it up, and I'm like, oh my God, I've had this my whole life, and now I understand how to work with it, and I don't black out as much. So that's great.
Yeah. And one caveat to that, again, is that's specific to THC, right? CBD actually doesn't have that same effect. And so CBD, my supervisor actually published a paper with a colleague of mine. So if you just look up, it's Neri and Singh paper. And so that's your autonomic nervous system being kind of dysfunctional, right? So your autonomic nervous system is the nervous system that is in control of your body without you consciously telling it what to do. And the easiest example is if someone jumps out and scares the crap out of you, your heart rate goes through the roof. You did not tell your heart rate to go through the roof. Your body was responding to its environment. Why did your heart rate go through the roof? Because you went into a sympathetic overdrive and your body thought, I'm under attack. I need oxygen. I need glucose. And that's what you get when your heart rate goes up, right? So your autonomic nervous system really is in POTS. That is what is, it's off kilter. And so they published a paper, again, it was post-concussion because POTS, people that have concussion often have similar sort of symptoms, right? Like it's an umbrella thing where and no two concussions are the same. But when your autonomic nervous system is off kilter, what you're trying to do is regulate your ability to flip between sympathetic and parasympathetic autonomic nervous system. Sympathetic is your fight or flight, and your parasympathetic is your rest and digest. And so if you're chronically stuck in one or the other, you can't regulate yourself properly. So in their published paper, they used CBD, and they were looking to see, so we can use heart rate variability as a proxy measurement to look at your autonomic nervous system and see, is your autonomic nervous system good? Like, is it flexible? Is it responsive? And we use it in athletes a lot to see, are they ready for harder training? And so if they have a good heart rate variability response, we know that their system is recovered. If they don't have a good heart rate variability, then we know that their system's under pressure and they haven't recovered yet, right? So they used CBD in this publication, and they were able to increase these post-concussion, they were female post-concussion patients. They were able to increase their heart rate variability using CBD, which is an indicator that they're able to massage the autonomic nervous system back into a place where it can be flexible to get out of the overdrive of sympathetic or overdrive of parasympathetic and get it back regulated into homeostasis.
Wow. Well, thank you for that. I definitely am going to go and read that paper. I'm a nerd for the autonomic system, well, mostly because of my own issues, but yeah. I'll go look that up. Thank you. Let's talk a little bit more about vasodilation. One of the classic signs of somebody being stoned is that they've got bloodshot eyes, and it was actually in preparing for our chat today that I found out that it's not about having dry eyes, which is what I always thought it was. It's because the blood vessels in the eye have vasodilated and they have widened. And so now we can see them in the eyes. Do you know of any good solution for bloodshot eyes other than eye drops? Is there anything else that we can do?
No, I don't know of anything better than eye drops.
I don't either. I figured I'd throw that in there though.
No, definitely not. But again, context matters, right? That can be an advantage when we're looking at people that have glaucoma or they have pressure in their ocular. So we want to dilate that because what are we doing? We're getting more oxygen and blood flow to the places they need to go, right? So yes, for sure. But I don't know anything else other than
fair enough. So with the cardiovascular system, we started by talking about how intimately it is connected with the endocannabinoid system, where they more or less occupy the same space and they have a lot of the same participants. And but when we talk about it, we're like, okay, the cannabinoids, they go through the lungs and into the bloodstream and then, to all of the receptors around the body. And the idea that the cannabinoids, the phytocannabinoids that we have entered into our body, just somehow get in the blood and then the blood moves around the body. Is it as basic as that? I mean, that's how it looks in the grade school, animations of how the body works. Is it that simple? It seems like the cannabinoids would have a long way to go to reach all of the receptors in the body. And are the receptors on the periphery less likely to be activated?
Yeah, so the thing that's really interesting about the endocannabinoid system is it's a compensatory system. And so when you think about, and that's why it works so well for so many different things, when you have an injury of any type, so now you've entered in the cannabinoids into your body, right? And it's circulating around. So remember, you have and we'll just talk about the two very basic ones. CB1 is on basically central nervous system. CB2, it is in motion circulating on your immune cells, right? Primarily. Those CB2 receptors, they're moving. And that's why pharmacologically, it's like a moving target. And now when you have an injury, so if it's an injury in your brain, for example, like concussion, or even an injury, any kind of neural injury in your periphery, there's an upregulation of those CB1 and CB2 receptors, meaning you have way more targets. So if you think about it like little birds in the nest, all of a sudden you have like 30 birds in the nest waiting to be hit when there's an injury. And so when you can send in the cannabinoids, it's going to be more effective at the places that it's needed because there has been a compensatory activity of the endocannabinoid system to upregulate those CB1 and CB2 receptors. And there's changes in other things, but we can harness that as an advantage advantage, again, using it pharmacologically, because knowing this, and we know with neurodegenerative disorders, again, I know I'm talking a lot about the brain, but that's where I spend my time playing. But if you think about the neurodegenerative disorders, we know that CB2 upregulation in microglia, which are basically the resident immune cells in your brain. Now, again, people think CB2 is only in the periphery. It's not. You have CB2 receptors in your brain on your microglia, which are the immune cells of the brain. When you have any kind of neuro trauma or just even a metabolic crisis, those CB2 receptors upregulate. And we know that that's the common denominator for almost every neurodegenerative disorder. So we're talking ALS, Alzheimer's, Parkinson's, MS, concussion, post-concussion, because when your microglia are aggravated, now CB2 receptors are upregulating. And we see that in all neurodegenerative disorders. And that means to me that when you're aggravating any kind of nerves, but now we're talking about the one in your brain, the immune system around it is playing a massive role in the crosstalk between those two systems. And we know that in the brain. We know that if we hit that CB2 receptor, we can flip the microglia out of a pro-inflammatory state, which they're throwing all kinds of pro-inflammatory cytokines and chemokines. We hit it, it can flip into an anti-inflammatory state, and now it's not throwing those things and it's more throwing anti-inflammatory molecules, right? And so by reducing that, and that's why we think, like in our clinical trial, that we can use the receptors to our advantage, and the fact that they do change. So it's not as simple as what you said, it's rolling through and your body's rolling through. Your body is a very dynamic system that's always changing itself. And so there will be different places where you have more adhesion molecules and different things. And so as it rolls along, it's going to, CBD is a really good example of this. When you have an injury, and your blood cells are rolling along down your blood vessels, it gets sticky where there's an injury. So it's like adhesion molecules, and the CBD rolls along, and as it's rolling, all of a sudden it's like Velcro. It's stuck. It's stuck. Your blood vessels get stuck, right? So when CBD goes there, it actually can reduce those adhesion molecules, which means that it kind of smooths it out, so that now you're not going to be pulling all those pro-inflammatory things there that are going to end up causing a problem. So you can, again, it's depending on what's going on in your body, but it's the cannabinoid molecules are circulating and doing the exact things as the rest of your body is doing, which is patrolling and checking out what's going on. And then based on what's going on in those areas, it will, act accordingly, type of thing.
That's interesting that it changes so often and there is such variability. And I think that's kind of the case with anything that people have got to learn. It's got to be super simplified so you can explain it to people. But when we get really into the nitty gritty of it, it's way more variable and difficult. And the idea that the receptors are on the move is something I had never thought of either. I always kind of considered them like they lived one place, and it makes it a lot more of a hunt and seek adventure. So, before we're about to go to break here, our first break, but before we go to, I just want to say, Dr. Thompson, how much I appreciate having a newly minted PhD like yourself on the show. You are so up with all your vocabulary and all of the new science. I just get excited and smiling just listening to you talk, because you're so clearly in the midst of the cutting edge right now, and it's really it's a real joy. So thank you for that. You'll hear more of that praise at the end of the show. So we're going to take a short break and be right back. You are listening to Shaping Fire, and my guest today is neuropharmacologist Elizabeth Thompson. Fish Poop brand fertilizer is an all-natural, OMRI-certified fish poop concentrate with nothing added. Real fish poop is extraordinarily complex. Not only are you adding the nitrogen, phosphorus, and potassium your plants need to build mass, transport nutrients, and enhance flavor, but fish waste is also packed with probiotics and micronutrients. When you add fish poop to your irrigation water, you are adding fertilizer in a form that strengthens the soil food web in your garden. Because plants are limited by the absence of any essential micronutrient, these trace nutrients are the difference between having a decent garden and having a garden that makes you feel really proud of your efforts. Fish poop is a naturally complete solution that fills in the cracks in your fertilizer program to ensure that you offer your garden a broad base of nutrients. Not all fish poop is created equally. Most products with added fish waste don't reveal their sources or lab results. Fish Poop brand fish poop, however, generates their own fish waste as a byproduct of their organic aquaponics cannabis farm where they raise ornamental koi and tilapia. You are even invited to tour their farm in person or on their YouTube channel to look for yourself. This sort of transparency is wildly rare in the fertilizer market. The folks behind Fish Poop are also lifelong medical cannabis producers who have deep connections in the community, donate more product than they sell, and support cannabis prisoners, veteran, and patient collectives and charities. To get your bottle of pure fish poop, go to fishpoop.com or search for Fish Poop on Amazon or Walmart.com. And to see their entire line of cannabis products, go to ounceofhope.com. That's Fish Poop brand fish poop. The new finely screened living compost from Leighton Morrison at Kingdom Aquaponics is in a product category all by itself. Nearly all compost you can buy is thermophilic, meaning that the compost pile has been heated in order to destroy all the pathogens. This composting process leaves you with only thermophilic organisms while killing everything else. Living compost from Kingdom Aquaponics is never heated above 115 degrees, so it still thrives with the phosphate and potassium solubilizers, degraders, and decomposers, along with the more advanced nutrient cycling organisms. But you might be thinking, Shango, if the compost is never heated, isn't it filled with pathogens that might hurt my garden? All of Leighton's compost components are specifically chosen and pre-processed to remove pathogens before the cool mesophilic composting process. The mushroom substrate he uses is sterilized in advance for growing mushrooms. The wood fines are from shredded kiln-dried lumber, and that kiln heat removes any pathogens. And the repurposed coco coir is sterilized with heat in advance too. These materials are then combined with a mix of worm castings, fish poop, and special biological inoculants that Leighton incubates and blends himself. The resulting compost has biological stability, structure and water storage capacity, is packed with nutrient cycling protozoa and nematodes, and is fungal and bacteria rich, including purple sulfur bacteria. He even provides the biological reports. This ultra-premium living compost is for anyone who wants to make compost teas, extracts, or top dress. You're getting 3 ingredients in one: worm castings, fish mulm, and biologically active compost all in one product. Get it right the first time. Buy living compost now at kingdomaquaponicsllc.com. Available in 3 convenient sizes. That's kingdomaquaponicsllc.com. As consumers become more educated and regulations become more demanding, it is increasingly important to avoid the use of chemical pesticides when cultivating cannabis. Beneficial insects have been used for decades by the greenhouse, vegetable, and ornamental plant industry, and today many cannabis cultivators are moving from sprays and chemicals to beneficial insects. Natural Enemies has the beneficial insects, mites and nematodes, microbials, sticky cards, and air distribution units you need to partner with nature to defend your garden. Whether you manage acres of canopy or have a simple grow tent in your home, Natural Enemies is ready to help answer your questions and help you transition away from chemical sprays towards clean and natural solutions. Natural Enemies was founded in the cannabis industry and continues to provide cannabis-specific guidance. Natural Enemies beneficial insects are grown with care and precision by Copert Biological Pest Control. Since 1967, Copert has assisted growers in identifying pests and devising reliable solutions while providing healthy insects and mites that will protect your yield. Since the 1990s, Copert has been a leader in cannabis pest and disease control worldwide and have highly trained consultants to assist you in Canada and the United States from coast to coast. Natural Enemies and Copert can help. Visit naturalenemies.com and get detailed information. You know getting away from pesticides is good for health and good for business, and Natural Enemies is ready to help. Visit naturalenemies.com today. Welcome back. You are listening to Shaping Fire. I am your host, Shango Los, and my guest today is neuropharmacologist Elizabeth Thompson. So, Liz, we were just starting to touch on the nervous system as we went to commercial, and that's where I want to pick up. And so, THC begins binding to those CB1 receptors in the brain, and those are responsible for mood and memory and time perception. Can you kind of explain to us a little bit what's happening biomechanically there? There must be a lot going on on that CB1 receptor, because it controls a lot of, nervous and neurological stuff.
Yeah, it really does control a lot of stuff. And again, context matters. So when we're talking about in your brain, so we're talking about moods and stuff, different neuron types have different concentrations of CB1 receptors on them. For example, like dopamine receptors don't directly, well, there's been recent publications that say potentially they do, but they would have a different concentration of CB1 receptors. The GABA neurons, like all the different neurons are a little bit different as far as how the CB1 receptors they function the same, but I guess it's the concentration of them. Okay. So when you look at how the CB1 receptor is working, again, for the context mattering, in a concussion, I'm just going to talk about concussion because you have mood troubles, right? Like mood changes, and they have a lot of different things happening. So we know in concussion that the neurotransmitter glutamate is being oversecreted, right? So that's a neurotransmitter where the presynaptic neuron is basically secreting into the synaptic space and too much of it. So it's out of control. So your endocannabinoid system, naturally, from the postsynaptic neuron, is going to secrete an andamide and 2-AG, which travels in retrograde, hits the CB1 receptor, basically shuts the calcium channels, and that shuts off the oversecretion of glutamate, which is something that we would want to do in concussion. And that was actually the premise of our whole clinical trial, was like, hey, do you think we could use these plant molecules? Because your endocannabinoid system does that itself naturally anytime you invoke any kind of, oversecretion of glutamate. But what if you can't? What if you can't actually hit those CB1 receptors enough to turn down the volume of that oversecretion of glutamate? And so that was my thought was, well, couldn't we come in with an exogenous molecule like THC, which we know is stereochemically similar to the naturally secreted endocannabinoids? Couldn't we come in with that plant molecule and hit that receptor and then shut down the oversecretion of glutamate as well? And so that's just one example. Now, that's in the context of concussion. When you're not concussed and you're just normal guy that's taking care of their brain and hasn't gotten smashed in the head, you're naturally... we kind of say that 80% of your brain is the brakes that are holding back the other 20% that's trying to like run away crazy, right? So basically you're under inhibitory control at baseline, right? Like when you're normal. So when you're normal, your GABA, which is the opposite of glutamate, which is essentially the brakes of, if you think of it like a car, glutamate would be the gas pedal, GABA would be the brakes. Basically, you're riding the brakes mostly at baseline. And now when you take THC, when you're riding the brakes, you still hit that CB1 receptor. And now it's going to shut the calcium channels. And what you're going to stop secreting is GABA. And now GABA is an inhibitory molecule. When you inhibit an inhibitor, you basically end up with an increase, right? So you're inhibiting an inhibitor. So basically what you're doing is you're taking the brakes off. So now what that does is it sends a signal to the dopamine neurons to secrete dopamine, and that's what is known as the high, right? So you're basically taking the brakes off, and now dopamine secreted, and that's where you feel good. Now, the biphasic nature, again, if you take the brakes off too much, you have a runaway train. You just took away way too much of the brakes, and now there's way too little GABA, and that's where the anxiety and paranoia comes in, right? And that's the biphasic part of THC anyways, is that, it's the dose that makes the poison in all medicines, and that is said to be true also with cannabinoids, because they are just as pharmacologically active as any other pharma drug we look at. It's just that people have a hard time wrapping their head around it because they're available in society, right? And they're coming from a plant, but they are absolutely pharmacologically active and doing pharmacological things the same way any other molecules are.
I want to just hit on the phrase biphasic, just for folks who are listening and that's new to them, because we talk about it quite a bit on the show. But biphasic means that a little of something is good and more of it is not so good. And THC is in that way, in that if you take, a small for you amount of it, it will, it's a euphoric and it's opening creativity and joy and all these good positive feelings. But if you take more than is appropriate for you, to put it in your terms, it takes off all the brakes and things get really loose and sloppy, to use my words. Yeah. And so you start to become anxious and paranoid and things go the wrong direction. Now, for any of you who might be thinking, I smoke all day and that never happens to me, it's because you've got so much tolerance that you haven't been, you're not experiencing the far side of biphasic, and maybe you need to take a tolerance break. But for most folks who don't have a wicked tolerance like I do, there is a point where you've toked too much, and you move. It moves from being a euphoric to what would that be? A dysphoric?
Yeah,
dysphoric,
sure. And CBD, that applies to CBD as well. It's not just THC. CBD is biphasic as well. People think that CBD is sedating by nature, but it actually is very biphasic. A low amount of CBD is actually alerting. Most people are stimulated by it. And if you don't push the dose high enough, if you're looking for sedation out of CBD, if you don't push your dose high enough, you're going to accidentally stimulate yourself. So if people, and this is where the education part comes in, right? And I'm super huge on educating consumers about how to use their cannabinoids the most optimal way possible. And you don't want somebody thinking, okay, well, I'm going to go use CBD because I need help getting to sleep. And they take a tiny amount and it stimulates them. They're trying to go to bed and they're like, what is going on here? Like, this is so not as sedative.
I run into this all the time with people who are buying CBD gummies at the store. And they're like, they never worked for me. I'm like, because they don't work like that.
Right, exactly. And again, that comes to the personalized applications, the personalized medicine type of thing, because it is a different amount. So, what is a high amount? Well, it's relative to the person, right? So what is a high amount for me might be a totally different high amount for somebody else, right? For them. But it is true that it's biphasic, that in a lower amount, CBD is stimulating and alerting, and in a high amount, much higher, than it can be sedating. But again, what is much higher? Well, that depends on the person, right? Mm-hmm. Some people, it's a lot lower than other people.
So let's move on to there is one more thing I wanted to hit here. It's often thrown around that CBD can stop you from getting high, right? It's usually how it's delivered, but I don't think most people understand the biomechanics of really, it's just about getting your turn at the receptor. And would you give a brief explanation of how CBD slows the progress of processing THC?
Yeah, for sure. Actually, Robert LaPrairie was actually one of my PhD committee members, and he was the person, I think it was in 2012, that actually discovered this and published it. And it was that CBD is a negative allosteric modulator at the CB1 receptor. And that's a mouthful, but what it means is, so in pharmacology, when you're looking at a receptor, you basically have, again, if you're thinking about it like a baby bird, the beak is the orthosteric pocket, and that's what you're trying to hit with your molecule. Now the neck, that would be that's where the allosteric site is. It's on the side of the receptor. CBD hits the side of the CB1 receptor and it turns the configuration of the top of that receptor, which means THC can't fit in there the same way that it used to when CBD wasn't on board. So by using some CBD, we can turn the orthosteric pocket slightly in 3D, in 3D space, which affects the way that THC can or cannot bind to the orthosteric pocket, which is basically the bullseye, right? That's what you're trying to hit, is the orthosteric pocket. So you need to have enough CBD on board in order to do that, to stop, if you're trying to reduce any kind of cognitive impairment, we would say at least have a 5-to-1 ratio. Some people say 4-to-1. 20-to-1 is, common for people, that don't want a lot of THC, but so it CBD changes the CB1 receptor. However, CBD does a lot of other things outside of the CB1 receptor. with direct agonism at some, the 5-HT1A receptor, PPAR gamma, the trippy ones, like CBD is it's very promiscuous. It's doing a ton of different things. Yeah.
I always love it when people say it's promiscuous. It seems so out of context.
Right. I picture it like walking around the bar with his sunglasses on, like, yo, what are you doing? Yeah. I just like, yeah.
Right on. So let's move on to our next system, and we've actually pretty well hit it. The next one I was going to talk about was the ocular system, but we've already talked about two of the three things, which is one, the vasodilation causing the blood vessels to expand in the eyes, and then also the general muscle relaxation that comes to the face from the THC. But one of the things I wanted to point on, just because we are both friends with Ethan Russo, and I'm a big fan of his research from 2003, 2004, showing that cannabis improves night vision. And they did this research of kief smokers in the Rif Mountains in northern Morocco because they would use hash before they would travel at night, because it would help them see at night, which honestly sounds like Dungeons and Dragons magic, right?
Yeah.
But just would you just hit on that just for a moment, pharmacologically, why that happens?
Yeah, so I don't know if I know enough to speak specifically to why their vision would be improved necessarily, but if you think on, and this is going to get like way into the weeds, but if you think about how your senses work, your eyes, your ears, your nose, it's all essentially transmission of ions, right? Like if you think of how your vision works, it's wavelengths of light, and those wavelengths of light are activating neurons and causing a signal. And so we know, epilepsy, for example, we know that it can affect the ion exchange, and that's how you calm the neurons down when babies are having seizures. We can use cannabinoids to do that. So we know that it's affecting the ion channels. And so when you're thinking about vision and how you actually interpret wavelengths of light, it comes down to physics. And actually, if you really drill down, so now I'm going way past molecular mechanisms and I'm going into like quantum mechanics. It is actually fascinating how many things you can change, especially and even in the endocannabinoid system, by changing ion channels. And what you're doing there is you're changing its physics, right? And we know in nerves, so again, in your eyes, it starts as an action potential, and action potential is an energy. It is not a chemical. It is an energy. And so I could see there being a place, if I'm just thinking in my mind, like, how would that work? Well, somehow, and it's night vision as well. Like I could see it working, but somehow I think it would get down to the wavelengths of light and the physics of it, and having something to do there. Also, you would have kind of the other things that are more broad, but like, your sensations are all heightened, right? So they're able to hear more, smell more. It's just like when you smoke and you go eat the munchies, because your taste is heightened. Everything is heightened, right? So the things taste better. Sometimes things smell better. Art seems to come better, but it's down to the action potentials in those neurons, which is essentially it's electric. And in that synapses, even muscle movement, it starts as an action potential, which is electricity, which then gets changed to a chemical signal at the synapses of the neuron. And so in concussion, we're trying to control the action potential, which is electricity. And I think that the endocannabinoid system essentially is it's like a transistor. Like you are controlling energy. You're manipulating the electric loops, basically.
That was great. When you said that you were going to take a left and go into the weeds, I knew it was going to be good, because when scientists just start riffing, that's kind of my favorite part of the show.
Okay, well, none of that has data behind it, by the way. That's just me thinking, because you are here as the person who has got the biggest picture of anybody who's in the room with us right now, right? So your what do you call that? Your speculation is very valuable here. I want to ask you a follow-up question that I was going to ask you during the third set, but since you're talking about performance right now, and how it can expand with cannabis, I was curious,
coming at it from I know that you work with high performance individuals, but let's think about this same thing with like regular performance individuals, right?
Yeah.
Some of us have had the experience of we like playing like whatever our sport is, let's say ultimate frisbee, right? We like ultimate frisbee, but when we play ultimate frisbee a little stoned, we're epic at it because we see all the trajectories so much better. And when I was younger and I spent more time in bars, I would hear that same thing about friends and they're playing pool, right? Yep. They'll be all like, oh, I need to go out and have a puff because we're going to play these guys for money or whatever, right?
Yeah.
And yet there is this biphasic, again, I'm not sure if it counts in this place usage, but there is this point where you've smoked too much.
Yeah.
And your motor skills are lessened and your attention lessens and everything lessens, right?
Yeah.
Is there a threshold point in us that it goes, oh, now you're over? I'm assuming that it's not a single point threshold, that there's a series of thresholds, but I think you know where I'm getting at. So what's this difference between improved coordination reaction time versus, oh, now I can't play?
Yeah. So, $1 million question. But again, I will say context matters. And because we're talking about athletics, this is really my wheelhouse. And this is places where I spend a lot of time thinking. But if you think about what sport you're playing, I think that changes the bullseye target of what you're trying to do with cannabinoids. When you have extreme sports, like I was a downhill ski racer, okay, like you cannot be afraid. If you want to go as fast as possible and win, you better chillax and just go as fast as you can. Now, using cannabinoids in that context can be quite an advantage because you become very brave. And now I have worked with elite athletes that are goaltenders in certain things, and it makes them very brave. They're not afraid to take shots of things that are, like lacrosse balls that are really hard. They're going to hit you, whatever. It makes them brave. And so now in the context of those things, can you surpass the point of, the optimal point? For sure, because you don't want to make yourself more afraid. You're trying to be brave, right? So there's definitely a threshold there for sure. And in those types of extreme sports, what you'd be using it for would be different than something like pool. Now, pool, you're looking for precision in your muscle mechanics, right? You're looking for precision on how you're moving your pool cue, and that's different. You're not looking to be brave. You don't have to be brave to play pool. You're trying to be precise. And so to hit the mark on that one, you're trying to probably, it's the same reason why CBG sometimes works, like in Ethan Rousseau's recent publication showing that increased memory verbal recall but in association with it reducing anxiety. Well, if you've reduced anxiety, you have more capability to pay attention to the things that are important, and then you can retest with your memory recall. In pool, I would argue that it could be like that, where you could use cannabinoids to reduce the background noise of all the things that are distracting to when you're trying to pay attention to this very precise movement. Now, another sport like pool would be, those biathletes that have to do the shooting, you need to hold really still and focus. And so I think some sports are more affected than others. We look a lot at contact sport athletes. And so we're looking for the purposes of neuroinflammation in the brain, how cannabinoids can work for that. And my big question for that is exactly like you said, okay, we know it can reduce neuroinflammation, and we know, we think, right? We know in mice, we've conked mice in the head, and we know that it reduces neuroinflammation, all these things. But mice are not elite performers. And at the end of the day, when you have a $50,000 or a $50 million athlete, you cannot screw up his reflexes. You cannot screw up his cognitive ability to make a play. You cannot screw up all of these other things, like his reaction time and all those things. The trade-off is you have to be so careful, right? And cannabinoids can help, but they can also get you off your game, right? And so that is the $1 million question, is how do you use these, to help with these athletes specific to their sport in the best possible way. And I know basketball, so part of my PhD research, I actually did a lot of interviews with high level athletes. And, so I got a lot of really good firsthand information. And we all know, it's no secret that the NBA, they have a lot of cannabis use, right? And a lot of I think a lot of fans are like, man, they're such good players with cannabis. Imagine how good they would be without it. But that's actually not true. When you ask them, like, so why do you use, why are you using cannabis products before practice or before games? And they don't say it's to enhance a performance. They say it's to feel normal. They bring themselves into a range that to them is where they normally perform. And that to me was so interesting because it was like, not at all what I was expecting to hear.
That reminds me more of like state-dependent learning, how we used to say, well, if we studied stone, we should go take the exam stoned in college, right? It reminds me a lot of that.
Yeah, and it could be that, because they've always played that way, that's how they feel normal. But it could also be that it's knocking out a lot of background noise and they can get into what we call flow. Mm-hmm. It's where you're just moving and your body's moving and you're making reactions, you're making plays, and nothing else is penetrating your mind but this game. And actually, sports remind me a lot of the endocannabinoid system because sports is one of the only places in the world where it is happening here and now. It is not based on the past. It is not based on the future. It is right now. We don't know who's going to win. We don't know what the next play is. And the endocannabinoid system is the same way. Your endocannabinoid system is working in the here and now. It is compensatory and it is secreting and it is reducing in the here and now. And so when you kind of take a broader look at it, it's really interesting to me how we could, how these things all kind of overlap, maybe more at a philosophical level, but...
Well, they do overlap, and this is perfect because the next system I wanted to talk about was psychological and cognitive states, right? And that's right where we're moving into. The literature on this often refers to it as neurochemical rebalancing, right? Which it's interesting because that's a new term to me, which I love. I think of it more as like, changes in focus, sensory awareness, like slowing time, getting the giggles or feeling philosophical. Like we'll talk about, this kind of cannabis might put you in this mood or that mood. And I tend to think that, okay, sure, there's some research on terpenes and esters and things like that. But more than anything, I think it really depends on the person themselves who is using it. I love your example earlier about the soil that you put the seed in, right? Yeah. If the person is the soil and the THC and the cannabinoids are the seed, it really depends on what kind of soil you put the seed in, what it's going to grow into. I will be using that a lot. Yeah. But this idea of neurochemical rebalancing at speed, I wanted to ask you about specifically as a neuropharmacologist. This is your turf, right? Yeah. What does neurochemical rebalancing mean? And what does that how does that show up in the first few minutes, let's say in the first 5 minutes after we toke?
Yeah. So again, you have to think about the context of what you're talking about, right? So when you toke, before you took that toke, your brain was sitting at a baseline level. So we'll just call it your baseline level. So you had neurotransmitters that were just kind of humming along, like your serotonin, dopamine, GABA, glutamate, all of those things. So when you take a toke, now you've introduced a signaling molecule that actually reacts with, like, independent, again, like you said, whatever the cannabis profile was is actually going to be different as what the signals are. But once you introduce it, it's starting to hit targets on all of those different neurons in your brain that actually control the secretion of serotonin, dopamine, glutamate, GABA. So what you're doing is you're changing the resting baseline. So you can call it rebalancing, you can call it unbalancing, you can call it, there's a lot of different words that you can use. But at the end of the day, you're sending in a new signal. And we use it. That is why we're looking at it for a clinical trial, because we want to use this signal to our advantage to reduce the glutamate secretion, which in concussion is totally out of control. Now, if you're looking at anxiety or depression or other mood dysregulations, when things are dysregulated in your neurotransmitter profile, we can use cannabinoids to try to change that and re-regulate it, which is what you're referring to as a re-regulation, because your body at the end of the day, the end game for your body is to survive and it's to be in homeostasis, which means balance. And so when things are out of balance, your body is looking to re-regulate it, to bring it back to homeostasis. And that's why the endocannabinoid system is truly so fascinating, because there's so many avenues to doing that. And because it is the active participants are your neurons. It is a neuromodulator, but it's also an immunomodulator, which is all your immune system. I think people sometimes ignore the immune system part, but that's everything. All pathologies in our body are because either one or the other of those are dysregulated. I mean, cancer is a perfect example, right? Like when you have something that's gone awry in a tissue or in a nerve or in anything, your immune system now is activated, and these cells go out of control in cancer, but your immune system is responding to that, right? So the crosstalk between those two is super important. And so it's important to remember both pieces, not just the neural part, but also the immune system part. And so in your brain, where we're talking about mood and stuff, it's only just very recently that we've given any credence to the other parts of the brain other than the neuron. So we have the neuron, and for a long time, people, it was all SSRI inhibitors, which again, it's like, okay, yeah, you can inhibit the reuptake of serotonin, that's fine. But like, if you don't have serotonin receptors to hit, or there's something wrong with your serotonin receptors, that's not doing you a lot of good to, slow down the reuptake. It's like, it's this myopic view of the entire thing, right? And I think pharmacy's gotten a little bit myopic on what they're looking at, instead of, you have to remember that, like, and the endocannabinoid system is amazing in considering that, because it's very evident that, yes, there's the ligands that we secrete, which are anandamide and 2-AG, just for simplicity, but the receptor concentration and the receptor availability is also super important, and that's easily displayed by tolerance. We know we're changing the receptor concentration, but also the enzymes that are required to make the ligands. Well, that's also something that's super important, right? So it's not just about the neuron, but what we've ignored in mood dysfunctions and stuff up until very recently is all the other players in your brain, which, other than the neuron that's secreting the neurotransmitter, your neurons, they have astrocytes. So all the glial cells, which are astrocytes, which are basically like providing energy to the neuron and making sure the neuron's got enough for metabolic processes, but also those microglial cells, which are the resident immune cells in your brain. We are now starting to have some really good data and research to show, like, when your microglia are freaking out in your brain, that is not a happy situation, because it is freaking, it starts throwing pro-inflammatory cytokines and chemokines, and what that does is it aggravates the neuron. So now the neuron starts throwing more pro-inflammatory things, and this is just like this big snowball feed-forward effect. We now know that mood dysregulations actually have, the microglia are super perturbed. So we always, for the last, 30 years, it's all about the neuron, but like, I mean, way back when we used to throw out the glial cells and be like, yeah, this isn't important, let's just study the neurons. It's like, those are really important. Like, we should not have been throwing them out. And we're just kind of catching up, I think, now.
What a crazy idea that, like, you toke and maybe you get into a little funk instead of the normal good mood. And you can think about it as like, oh, my glia are over antagonized.
Yes. Right.
It really gets down to our mechanics right there.
Yes. And they have their own, like, your microglia and your astrocytes have their own endocannabinoid functions. Like, they themselves secrete anandamide and 2-AG, and they themselves have CB receptors on it. Right. And so when you're looking at, and then you go right down to, like, even the mitochondria, which, we all know from grade school biology, that's the powerhouse of your cell. That's where the electron transport chain happens that produces ATP, which is the energy of your brain. Again, electron transport. Now we're getting into energies, right? Those mitochondria have CB1 receptors on them as well. And that is inside the cell. That isn't even a CB1 receptor on the outside of the cell. This is a separate population of CB1 receptors that are inside the cells, in the mitochondria. And your mitochondria are driving absolutely everything in your body. Most importantly, your brain. When we have brain fog, quote unquote, when we have concussion, quote unquote, your mitochondria cannot produce enough ATP, which is essentially the gas that's running your whole system. So if we can do things that support that to create more ATP, then that's a benefit to us. And that's where, like, the ketogenic diet and fasting and all those other things come in, because we're able to start using fat as a fuel source to create that ATP. Now, I personally think the endocannabinoid system is a bridger between using fats as a fuel source, which is a much higher dense, it's a dense amount of ATP compared to like a carbohydrate source, right? And so in athletes, that's everything. If you can provide your system with more ATP, you are winning races. Now, glycolytic sports are fast twitch muscle. That's different. Now you're going anaerobic, right? And so you need your creatine. That's a whole different thing. If you're a long distance athlete and you can pull on fat stores to give yourself like 132 ATP versus the 32 you would get from carbohydrate, that's a win, because you are going to fuel yourself better and longer. Your endocannabinoid system is in control of all the bioenergetics in your body as well. And that's why, it was a tragic example, but Rimonabant was a drug by Sanofi that was pulled off the shelf in 2012. It was a fantastic weight loss drug, but it was a CB1 inverse agonist. And so it was a big lesson to everybody in pharmacy. Like, you can't just go, like, the thought was, okay, you hit the CB1 receptor with THC and you agonize it and everybody gets the munchies, right? You're hungry.
Yeah.
Well, the thought was, well, what if we just block it or antagonize it? It was an inverse agonist. So the thought was, let's make it do the opposite. So would we get like the reverse munchies? So they used an inverse agonist on the CB1 receptor, and it was a fantastic weight loss drug. It was. People lost weight, a ton of weight.
But you lost all the other advantages you get from having that on.
Well, the problem was, you lost all those advantages, but it caused suicidal ideations and mental dysfunction.
Jeez.
So that is a big lesson to, like, we are not playing in a tiny space here. And that was a tragic event, right? So it got pulled off the shelf. It never passed the FDA approval in the States. But what was really fascinating, and we could learn so much from that, was the people actually started to lose weight before any of those things started to change in like the brain profiles. And so what it says to me is that something was happening there, that we were able to change the bioenergetics of how we were using the fat and the available metabolism in our body before the brain part started to change, right? And so there's really good published research now looking at how cannabinoids can change the bioenergetics of your cell. But I think it's everything, because it has to do with your mitochondria and the microglia, because they also need energy. And I think once we start focusing in on that, we're going to have the answers to a lot of problems that right now don't have good answers, and they don't have good pharmacological products. Like concussion's one of them, right? Concussion doesn't have a pharmacological option that you can give somebody afterwards. But when you actually look down at the molecular level of what we can do with cannabinoid molecules, you get all the way down to the mitochondria, where you're affecting the bioenergetics of a brain that's in crisis. That's everything. We know that these athletes end up down the road with neurodegenerative disorders 3 times higher rate than normal people that didn't play contact sport. Well, why? Because their brains are perturbed and they stay perturbed. So if we can turn the rig around, now we know that we can potentially reduce the neurodegenerative problems that they're seeing down the road. And CTE is just a result of that. Now, that's only diagnosable post-mortem, but CTE is the result of a very perturbed, it's a metabolic crisis when you get a concussion, right? And it goes into all these other things, but it's a metabolic crisis where you can't get glucose to that part of your brain and you don't have enough energy. And the downstream problem of that, it starts throwing sparks and problems all over the place, right? You go into an anaerobic, your brain literally goes anaerobic, like the way that your quads burn when you sprint too fast and you can't get oxygen to them. Your brain is going anaerobic and you're secreting lactate. Well, with that comes acidic products, and with that, your brain is not happy. Now, lactate is used as an energy source, and it's actually in a glucose sparing environment. Lactate's very beneficial. But the acid and everything else that comes with it, you don't want your brain to be anaerobic. You want your brain to be going in oxidative phosphorylation, where it can use oxygen and it can be happy and produce, ATP, and everything's balanced. Concussion's not balanced.
Yeah, totally. That's for sure. All right. So we see now how, actually, those are a whole bunch of different examples of how cannabis use is going to play a role in our psychological and cognitive state, especially with neurotransmitters. Yeah. And so when we come back for the third set, I want to have continued discussions about edibles and suppositories versus smoking, the time for delivery, which is what we started the show with, and also clean up a couple other things that came up during the show. So, dear listener, hang with us. We will be right back. You are listening to Shaping Fire, and my guest today is neuropharmacologist Elizabeth Thompson. And, remember, without these advertisers, Shaping Fire wouldn't happen. So please support them and let them know you heard them on Shaping Fire.
One of the challenges with buying autoflower seeds is that often you'll have as many different phenos as you will have seeds in a pack. That can be fun, sure, but so many varieties in one pack is a sign of an immature seed line that hasn't been worked enough. I prefer my autoflowers to be worked enough that each pheno in the pack really captures the aspects that the breeder was intending. This is why I recommend Gnome Automatics to my friends and listeners who grow automatic flowering cannabis seeds. Gnome Automatic seeds are not just crossed and released. They are painstakingly sifted again and again, tested in a wide range of conditions, and taken to a level of maturity that each plant will be recognizable by its traits. Traits that were hard-earned so that you can have your best growth cycle ever. Over the last 10 years, Gnome Automatics founder Dan Jimmy has become a trusted breeder, and he continues to pour his passion of breeding cannabis into every variety he releases for you to grow. Check out the Gnome Automatics Instagram at gnome_automatics to see the impressive plants folks are growing. You can score Gnome Automatic seeds in feminized or regular at your favorite seed provider listed in the vendor section of their website. Commercial cannabis farms across the country love growing Gnome Automatics because of their consistency from seed to seed, short grow times, THC percentages, and colorful bag appeal. Farms interested in bulk seeds of more than 1,000 should reach out through gnomeautomatics.com. While on the website, be sure to check out the Gnome Automatics shirts and other merch section too. If you want reliable seeds, hand-built from effort, expert selection, and experience, choose Gnome Automatics. You've heard me talk about the award-winning cannabis seeds that come from the analytical breeding program of Seth and Eric Crawford, who founded Oregon CBD Seeds. In fact, Seth was a guest on Shaping Fire in 2020 to talk about triploid genetics. Seth and Eric are now releasing high THC seeds for home growers and farms as Grow the Revolution Seeds at gtrseeds.com. Their high THC seeds are extraordinary in that they will start to flower at 16.5 hours of daylight instead of the typical 14.5 hours of daylight. That means in most regions, your plants will start to flower outdoors in the middle of July instead of the middle of August, which means these photoperiod plants finish in September and not October, totally upending the photoperiod seed market. Seth and Eric took their prized early flowering CBG line and bred it to some of the most desired verified genetics out there, including Sour Diesel, Triangle Kush, Wedding Cake, Chemdog, Skittles, and others. These crosses all express powerful photoperiod terpene profiles and THC, giving you a great high. GTR Seeds has a new THCV line with plants like Double Durban and Gigantor that boast 1-to-1 THC to THCV, and people want that THCV. GTR seeds are very consistent, true-growing, inbred F1s from stabilized inbred parent lines. These seeds are nearly homogeneous, and the plants should all grow the same. There is only one phenotype in every pack, available as diploids and triploids. Seth and Eric's company is still family-owned, patient and employee-centric, and partially powered by their 2 acres of solar panels. Everyone can purchase these seeds and the entire catalog of Oregon CBD seeds at gtrseeds.com. Go to gtrseeds.com today and choose something revolutionary for your next indoor or outdoor run.
This message is for folks who grow cannabis. I'm talking to home growers, patients, and commercial growers too. I'm probably talking to you. When you plan out your next growing cycle, be sure to check out Humboldt CSI seeds at humboldtcsi.com. Caleb Inspecta and his family have lived in Humboldt County for over 100 years. For the last 40 years, 3 generations of his family have cultivated extraordinary Sensimilla cannabis in Humboldt, Mendocino, and Trinity counties. Because of his lineage and the hard-earned experience that comes from growing up, smoking, and sifting large populations of cannabis plants in Northern California, the seeds you'll cop from CSI will be winning genetics based on longtime heavy hitters and updated and resifted to bring out new and exotic traits and better yields. Go ahead and ask around. Caleb, also known as Inspecta and Pirates of the Emerald Triangle, is a breeder's breeder. He reaches way back and works with significant strains, recreating them in new and interesting ways that you'll love as a toker and a grower, as well as offering you some surprises that will delight serious seed traders and cultivators. Humboldt CSI goes a further step and selfs all these chemovars so you know all the seeds will be female. These are not experimental feminized seeds. Humboldt CSI releases some of the best female seeds available anywhere, and it will show in your garden. Folks grew quite a bit of CSI Humboldt Genetics last year here on Vashon Island, and everyone was pleased. The patients had beautiful female plants and didn't have to cull half of their garden as males. The folks growing for the fun of getting high grew colorful flowers with exceptional bag appeal and great highs. And breeders had 7 out of 7 females in a pack, which gave them a lot of phenotypic choices. Take a moment right now and visit HumboldtCSI.com. You'll find an up-to-date menu of both feminized and regular lines, along with photos and descriptions. That's HumboldtCSI.com. Welcome back. You are listening to Shaping Fire. I am your host, Shango Los, and my guest today is neuropharmacologist Elizabeth Thompson. So let's talk about the different modalities, I guess we'll call it, of actually getting the cannabis or the cannabinoids into your system. As we talked about at the top of the show, we've been mostly talking about smoking. Liz put it perfectly: fast in, fast out. It comes on really fast, but then it also gets processed and goes away the fastest. And we alluded that there were other reasons to use other methods, which, you know, everybody here, we all know cannabis medicine, right? And we all know that sometimes edibles are more preferred for, you know, a range of reasons. Either the person has gut issues, so they can't put things through their gut, or they're not processing things properly, or it causes its own reaction, or maybe they are looking for a different kind of relief than the fast in, fast out. Maybe they've got more of a body issue and they need more of an aches and pains issue, right? So as we've been talking about, there's lots of different patients, and so there's lots of different reasons. But what I want to talk about at this point is the different functioning of the edibles. So Liz, I want to talk about 2 different types of edibles. There is the food kind of edible that gets, you know, chewed up and swallowed and then processed. And then there is the capsule with RSO version of an edible that we eat. But that capsule is going to degrade earlier in the process, and that cannabis oil is going to get likely soaked in through tissues, esophageal tissues on the way down. I'm guessing, right? So feel free to correct me on that. So what I'd like to start with is, would you kind of explain to us the path that the cannabinoids take when we are taking an edible that is food-based, like a gummy or a cookie, versus taking a capsule that's got oil in it that breaks down faster?
Yeah, for sure. So I think with the capsule, actually, it would really matter on the cellulose container that you had it in, just as an aside. So if you had it in a capsule that was going to make it to the stomach, it would be essentially digested the same way as the edible one would be. And I think one big thing, and in our clinical trial, this was really important, and the pharmacology of the cannabinoids is, again, you have to look at the big picture of, it's not just about the cannabinoids, it's also about what's in your stomach with the cannabinoids. So we know that when you take cannabinoids in the edible form and you take a fat heavy meal, so you want to take your cannabinoids with a fat, so we say, like, you know, peanut butter, cream, whatever, it increases the bioavailability 4 to 5 times. So we've done some studies looking at a fast versus fed. So, you know, when you're fasted and you have nothing in your stomach, your digestion process hasn't been turned on at all. When you're fed with just carbohydrates, you turn on a certain type of digestion. When you're fed with fats, you turn on another different type of digestion. Now, cannabinoids are lipophilic molecules. They are made of fat. So when you take your cannabinoids as an edible and you have fat in your body, it kind of mixes in, you know, oil and water don't mix, but oil and oil mix. So these 2 oil and oils are going to mix. And now we know, I mean, there's a lot of publications on the pharmacology showing that with a fat-based meal, the bioavailability does increase about 4 to 5 times. So that's something that's important when you're trying to look for, consistency and dosing and stuff like that. And it can affect the outcome, right? And so first of all, so that's the first thing that happens when you take either product and you put it in your stomach. It's, again, context matters. What is in the stomach with it? And we can see big differences between people. Even in our clinical trial, sometimes it's like, did you eat? Because this doesn't look like a blood profile that did. We can tell. You can't fool us. But so there's that. And then the other big thing that is important to consider versus, when we're talking about inhalation doesn't go through first pass metabolism, whereas edibles do go through first pass metabolism, which means that your liver is processing the cannabinoids. And that's actually really important. People think, okay, well, it just takes longer, but it's actually not about the time. It's about the chemical conversion that happens. So
I love that 11-hydroxy.
Exactly. So, and CBD does the same thing. So you have delta-9 THC when you take it as an edible, goes through first pass metabolism. So your liver starts working on it. And this is part of the digestion process. It converts it to 11-hydroxy THC. Now, 11-hydroxy THC is slightly more cognitively impairing. And so now it's actually a different molecule and it functions differently. And that's why people, quote unquote, they can green out because, one, it's the time factor, right? People sometimes will take an edible and they won't realize that because of first pass metabolism, it takes a lot longer to feel the cognitive effects. We say, 90 minutes to 2 hours before you're going to make a call of if you're going to take another gummy or something, right? Give it a chance. And so there's that time factor. But then secondly, there's the conversion factor to 11-hydroxy THC, which is more cognitively impairing. And actually it has a little bit of a different, shape. So it's potential that it can get up into your brain and then maybe stay up in there. And now, again, I hate that I bring everything back to concussion, but concussion, your blood-brain barrier is leaky, and that makes, again, the context different. Now, if you have a leaky blood-brain barrier, things can get up in there, and then if it heals, it can stay up in there, right? And that's actually one of the things that we can use to our advantage with CBD, because CBD can get up in there, and then CBD actually helps to seal the blood-brain barrier, and so that's an advantage, again, to using CBD for concussion. But anyways, back to the edible question. CBD also goes through first-pass metabolism, and it goes to 7-hydroxy CBD. And what we have to remember is those secondary metabolites are also bioactive. And so in some senses, 11-hydroxy THC is more bioactive potentially in different ways than delta-9. And CBD, same thing. That 7-hydroxy CBD is also bioactive. So it's not just a breakdown product, it's a bioactive component of its own. So now you're giving a whole nother pharmacological profile. And actually there was a recent publication on CBG, and it was looking at the secondary metabolites of CBG once it was getting broken down. And in the paper, they proposed that one of the breakdown molecules of CBG was even more bioactive than CBG itself. And so, when you're thinking of it from a pharmacy perspective, those are useful molecules, right? And so, epilepsy is an example that we always use with CBD, but it's potential that the breakdown, the secondary metabolites of CBD are as important as the initial part, and that's how it's functioning in your brain. So when you take an edible, it's completely different. When you inhale, that doesn't happen. Now, when you inhale, what does happen is the heating process can changes the profile of the cannabinoids and the terpenes and that. And so there is some chemical changes with the heat. When you're having an edible, the heating has already been done. So the heat profile has changed. Not to know if it's exactly the same as inhaling, but it has been decarboxylated to make it active, which people would say decarboxylation is. So when you eat it, now you have the first pass metabolism and all the rest of that's going into it. So it does make it quite different. And it lasts longer. So once you have it, it's not as fast in, right? Because of the time, and it's not as fast out. And so with patients, we know that we can hold the therapeutic value in their body if they're looking for pain reduction and stuff. You can hold the therapeutic value for longer because the metabolism takes longer, so you get the therapeutic benefits for longer.
That's the best explanation of how delta-9 THC and 11-hydroxy THC are actually different drugs than I've heard. Thank you for that. One of the things that we talk about when people are smoking, we say, the cannabinoids really only stay active in your body for up to 4 hours, much less when you smoke. And so, for people who have got chronic issues and they need to dose throughout the day, Listening to your explanation made me wonder, does the 11-hydroxy THC, does it last longer than that 4 hours? I kind of thought that 4 hours was about the maximum time that you're going to get activity from cannabinoids before you need to re-up. But I had never really thought about 11-hydroxy. I've only been thinking about Delta-9.
Yeah, I couldn't say for sure. I haven't actually seen any research on that, looking at, the area under the curve and looking at actually the time. So I don't know, but I know that the edibles in general do last longer. So I would think you could say yes, because you know those effects last longer than inhalation, right? So
yeah, just based on experience. Like all you need is a bad edibles experience, and you know it lasts longer.
Yeah, you want the clock to wind down. It's like, hurry up and stop. But yeah, so it could be to do with the metabolic process, but it could also have to do with the fact that the 11-hydroxy hangs out in your brain longer because it can't get out, and that is proposed that it's not the same as Delta-9 in that way.
It's just processed more slowly.
Exactly. And once it's up there, it's potential that it just hangs out up there longer, right, in your brain. And so it's, processed more slowly. And also, it's a bit of a misnomer to think like, okay, after 4 hours, you need to re-up. So you're thinking about, okay, well, what effect that you're after, but that THC can actually be stored in your fat cells, right? And so we have athletes, if they've used a lot of cannabis for a lot of time, even smoking, because it's a lipophilic molecule, it can be stored in your fat. And so if they're cutting weight and they're starting to lose fat, those THCs can actually come out into their bloodstream. And, if it's high enough, you could actually not have smoked or used THC for a really long time. But if you're cutting weight and you have stored THC in your fat, it can come out and start and make it really prolonged time before you'll have a clean test, like 75 days. Like if you're losing weight and the fat that you've stored has THC in it. So yes, the effects may be 4 hours, but the THC itself can still be in your body for like a really long time.
That reminds me of how we used to describe LSD flashbacks. Like, the LSD can hide in your body and someday you're going to use that fat cell.
Right. Yeah. Well, kind of thing. And it actually, yes. I mean, I don't know if enough would ever come out to be cognitively impairing, so to speak, but it can be enough to pop a positive test. And if you're an athlete that's going to lose his scholarship because of that, or if you're an athlete that's going to get a $20,000 fine or a suspension, you don't want that to happen.
Yeah, you want to be very aware of it.
Because you actually didn't use THC, like you're actually not lying. But if you're cutting weight and it's coming out of the fat stores and you're popping a positive test, both things are true. This athlete did not use cannabis in the last however much time that you're testing him for. But it is also true that it's showing up on his test, right? So both things can be true.
Wow, that brings up all sorts of DUI questions too that we are not going to get into today.
Yes.
Yeah. All right. So
sure.
let's wrap up this set by talking about suppositories, which always gets giggles when I bring it up in live panels. But it's one thing. Let's see. How do I want to say this? It's one thing to be a cannabis enthusiast. We love using cannabis. It is different when I'm working with a patient when they need cannabinoids to survive, right?
Yeah.
Their relationship with the cannabis is different. And I have seen and helped patients do everything, and come to the point of realizing they need to make their own suppositories, which is almost always a very sick person, and my heart always goes out to them. So let's talk a little bit about suppositories, because I know I've got a lot of these people in our audience. So let's first talk about the anal suppositories, and we're not going to talk so much about like making them and things like that. There's a lot that information is available pretty regularly, but one way or another, you're usually going to use some combination of RSO with coconut oil in some way, maybe some shea butter. Lots of people like to put them in the little freezer form things that you put in the freezer, and you make it hard and you just keep it in there. And when you got to use it, you just, take your finger and put it on into the rectum. Right. And while that is a extraordinary and odd and sometimes messy process, it's important as far as medicine goes.
Right.
And so it's from this point that I'd like you to pick up the story, Liz. Would you just tell us a little bit about how the cannabinoids find their way through the rectal wall and then into the system that way? Because it works. Even with all the jokes, it still works really well.
Yeah. Yeah, for sure. It does work. And all you need to do is have somebody that's actually felt high from that, which can happen.
Yeah.
Right? So it definitely works. And we know that it can get in there. And it's no different than any other medication that we use a rectal suppository for, right? And so it's getting absorbed in through that passageway, just like any other medication. I think the biggest, the difference between, the one thing to pay attention to is how deep you're putting it in. Because if it's lower down in the rectum, then you're most likely not going to go through first pass metabolism. And so that's going to go directly into your lymphatic circulation. And so it's going to start circulating that way. If it's pushed up a little bit higher, then it's potential that it's going to go into your liver, and then it's going to go through that first pass metabolism. And that's going to look different, just like we just said. So it's still going to do the same metabolic processes, but I think it's absolutely a valid delivery system. And that's for a few reasons. If you have somebody that has, like the patients that we think about that use any kind of suppository, for problems that are kind of from the belt down, but it's also for the amount. Like if they're trying to dose themselves at a high amount for, cancer patients or somebody
exactly.
it's definitely a valid administration route for sure.
Because you don't get as high.
Oh, exactly.
Yeah.
Yes, it's totally reduced, but you can still get the amount, a pretty decent amount in, and that's what you're after, right? You don't need the high to have the therapeutic outcome, and that's also sometimes confused in the world. It's like, no, you can have in fact, most patients don't want to be high. They want the therapeutic value without the high. That's what they're actually after.
Well, especially at cancer protocol dosages, right? If you're taking 200 or 300 milligrams a day, that's going to drive some people batty.
Yeah. Well, and the other thing is you also have to think there's a population that the cancer population is a perfect example. They're extremely nauseous and they're throwing up all the time. So what good's an edible going to do them? Nothing. They're going to throw it all up. Whereas if you can use a suppository, you can get it into them that way. Or, you can use inhalation, but that's fast on, fast off, right? So you don't necessarily want that either. You want to hold the therapeutic dose. And by using suppositories, you can do that. But the other place that I think suppositories are massively valuable, and I speak about this all the time, is for females. And I'm talking, well, you can still use it, rectally, but vaginal suppositories as well, because for premenstrual pain or any kind of pain down in the female reproductive system. And so I've worked with many athletes, and I've spoken about this a lot. Female athletes are crippled once a month from menstrual cramps, and it is not fair. And I'm so glad that the NCAA changed their regulations for just this reason alone. It was not fair that they couldn't use cannabinoids for this, because they work so well for this. Because if you think of menstrual pain, it is all types of pain. It is inflammatory pain, it is nociceptive pain, and it is neuropathic pain. It is all kinds of pain. And we also know that there are, second to the brain, the female reproductive system has the highest concentration of cannabinoid receptors. So if you're looking for a good target, that's it. And the closer you can get to the place where you're having the problem, by using this suppository, the better your results are going to be. And so you can get it, you can use it as a suppository, and there's some now available on the market, different ratios and stuff, but you're able to get it, to where you need it to go. And again, they're not looking for a high, clearly, but they're looking to actually be a more direct hit to the tissue and the nerves that are having the problem. And so endometriosis has quite a bit of good data actually on it, using cannabinoid products. Mostly it's, retrospective analysis and stuff like that. Like, they don't have clinical trials, but there is some pretty good data to show that cannabinoids work very well in that population. And we know in endometriosis that there's a massive upregulation of the TRPV1 channels. And we know that CBD is a direct agonist at the TRPV1 receptors, which is, also the capsaicin receptor, but it agonizes it to the point that it desensitizes it. And that's how it works in any pain in our body. But we know specific to endometriosis tissue that there's a a weird upregulation of these TRPV1 receptors. Like there's a lot of them. So why wouldn't you try to hit it with something that's going to desensitize it and reduce your pain, on top of the fact it's going to reduce the actual tissue inflammation and it's going to reduce any of the nerve triggering?
Wow. I'm thinking about that cascade of effects. Yeah. And it's interesting how selective it is, right? Because we think about the effects that happen medically from ingesting the cannabinoids. Yeah. But then when we're bringing them into the body through the anal or vaginal wall, it has different effects. And so it's like, yeah, you're kind of getting a selected subset of what cannabis can do, and it makes it kind of like a specialist for special patients.
Yeah, for sure. Because when you look at what receptors are upregulating there, they are very receptive to cannabinoid molecules. Like the TRPV1 is a target for any pain. But, you know, if you know that endometrial tissue has a high concentration of TRPV1 receptors, of course you should be trying to hit it.
This is also the best evidence I've heard for location targeting for your cannabis, right? I mean, we're all familiar with like, oh, you've got a sore shoulder. You know, use a THC topical with a carrier that can get through the dermis and put it on your shoulder directly. That's great. But this, using anal or vaginal suppositories, you can location or proximity target for anything that's going on in the whole hip area, you know, from the belt to the knees.
Yeah. Yeah. And the other thing too, just because we're talking about pain and like, you know, rubbing something on your shoulder, but
sure,
when you think about pain, and this again is a discussion that would be far beyond the amount of time that we have, but like, you know, the question is always, okay, well, where is the pain actually coming from? Is it coming from the location in the tissue where there's actual inflammation, or is it coming from your brain that's processing that signal? And that is how we can get in there with cannabinoids, because we can intercept the signal. And so, you know, you have an ascending pathway that's sent when you have an injury of any kind, whether it's menstrual or just any kind of pain, you know, your sensory neurons, again, now we're in the autonomic nervous system again, your sensory neurons are patrolling whatever, it's telling your brain, like, yeah, we got a problem, something hurts. So it's sending up, and your brain is interpreting that. With cannabinoids, we know, and then there's a descending pathway that comes down and it inhibits that pain signal, right? Okay, so if that descending inhibitory pathway does not happen correctly, then you're not inhibiting the pain signals. We know that the periaqueductal gray in your brain is pretty dense with cannabinoid receptors. And if we hit them and we activate that, then we know that we can increase the inhibitory path, like the descending inhibitory pain pathway. So to turn off the pain, right? Like shut it down type of thing. So we also know that by hitting that CB1 receptor with the ascending pathway, the afferent pathways that are going up to your brain to tell your brain something hurts, we can also intercept those with cannabinoid molecules. So because pain is a sensation, it isn't a thing. It's an interpretation of this signal, and it's a emotional response. And so I actually did a presentation on how we could use cannabinoids for, again, menstrual pain, but pain is also an emotional response, right? And we know the autonomic nervous system and the endocannabinoid system are bidirectional. So, you know, when your autonomic nervous system's freaking out, well, your endocannabinoid system's freaking out too, right? Like they go together.
That also explains why CBG is so effective as a pain reliever, not only because it can help with the neuropathic pain, but also specifically, it encourages the patient to feel like they can handle the pain, right? Exactly. It handles how they interpret the signal, which is a huge thing. You know, if you're going to be in furious pain all day, one way or another, you might as well be positive about it. And CBG really helps that.
Yeah. And the patients will usually say, like, and that's also too, like, you know, one of the indications that's most accepted for cannabinoid medication is neuropathic pain because where those cannabinoid receptors are on the nerve, right? We know that's a different type of pain than nociceptive pain, which is the pain of tissue. Like when you put your hand on the stove and you pull it off, right? Different thing. But yeah, I mean, it's when you talk to patients that are using it for pain, they will say, my pain is not gone. It's background noise. Mm-hmm. It's still there, but I can still function. And it's because you are intercepting the part where those pain messages were screaming at them and it was all they heard all day long, you can turn off the pain signals. Yes, the pain is still there, but you know what? It's in the background. I can still get on with my day and do my thing. So it's not taking the pain away. It's making the pain background noise, but, and chronic pain is different than acute pain, right? And we know that the brain changes when you have chronic pain. There are different areas of your brain that actually move from a state of like acute pain. It's doing some certain things. And once that turns into a chronic pain, the brain profile is different. And so we know that there's actually a shift. And so with chronic pain, that is one of the best indications that we get the best results from in pain patients is people that have chronic pain. And it's because of how we can intercept that signaling, right? Your body is one humongous signaling molecule. Well, a million signaling molecules, but it's just one big signaling thing.
One big collection, one big basket of signaling molecules.
Of signals, yeah.
Some days when I get all kind of like, flitterpated, I'm feeling overwhelmed. I'm just all like, too many signals are activated. Yep. Maybe I will go sit down. So
yes, exactly.
So Liz, thank you so much for joining us today on Shaping Fire. This was exactly the kind of talk that I was looking for. Your ability, your depth is obvious, but also your ability to put things in layman's terms so we can bring everybody along with us is really phenomenal. And so thank you for sharing your experience and your expertise with us so we could really dig into what happens in our body in the first 5 minutes after we toke.
Yep, for sure. I'm so happy to be here. And I am honored to be on your show because I listen to it a lot. So I don't really feel like I'm even qualified to sit in this chair, but I am so happy that I was invited on and it was a pleasure. Well,
congratulations on that PhD. We know you're qualified and I'll look forward to having you again on the show down the line when you have some new research to discuss. So thank you.
Yeah, absolutely. Anytime.
All right, my dear listener. So if you are interested in knowing more about Dr. Elizabeth Thompson, you can follow along with her work. The best place to do that is probably on Instagram. And that Instagram profile is trainwith.maryjane. Trainwith.maryjane. And you can keep up with all of Dr. Thompson's research and her speaking engagements and where she'll be online and webinars and all that good stuff. And then if you also want to keep up with the research long term, you can do so at trainwithmaryjane.com, which is where she publishes her research. You can also follow her on LinkedIn, but Liz was pretty clear that she is, she's a researcher's researcher, and that's where she is most of the time. And she doesn't have a lot of time to get back with people. So you'll probably do better to follow along and passively receive information on IG versus, trying to ping her with a bunch of letters. But, if you've got an idea to work together or opportunities, by all means, reach out to her at trainwith.maryjane. You can find more episodes of the Shaping Fire podcast and subscribe to the show at shapingfire.com and wherever you get your podcasts. If you enjoyed the show, we'd really appreciate it if you would leave a positive review of the podcast wherever you download. Your review will help others find the show so they can enjoy it too. On the Shaping Fire website, you can also subscribe to the newsletter for insights into the latest cannabis news, exclusive videos, and giveaways. On the Shaping Fire website, you'll also find transcripts of today's podcast as well. Be sure to follow on Instagram for all original content not found on the podcast. That's at Shaping Fire and at Shango Los on Instagram. Be sure to check out the Shaping Fire YouTube channel for exclusive interviews, farm tours, and cannabis lectures. Does your company want to reach our national audience of cannabis enthusiasts? Email hotspot@shapingfire.com to find out how. Thanks for listening to Shaping Fire. I've been your host, Shango Los.